Assalamualaikum and hi. Welcome to another video of chapter 3 polar coordinates for the subchapter of 3.4 areas in polar coordinates. From the previous video, we already know how to sketch a polar curves given by polar equation. So you have a straight line, you know how to derive a circle and also a cardioid. But for this video's lesson, we want to find the area which is enclosed within these polar curves. To begin with, we must know some of the fundamentals to find the area. We start with the formula of the area, which is given by the half of the integration from the ray alpha until ray beta, the angle, r squared theta theta. Because the half is a constant, I bring it outside, it still will give a similar result. There are also several trigonometric identities which will help you to integrate much better. The first one is if we integrate cos x, you will get sin x plus c actually. Second, if you integrate sin x is equals to negative cos x. When you involve a cardioid, there is a potential that you will involve cos squared theta. Cos squared theta is equivalent to 1 plus cos 2 theta over 2 to make the integration much easier. For the sin squared theta is equivalent to 1 minus cos 2 theta over 2. Remember these four trigonometric properties. Okay, we will start with the first simple example, which is a circle. Find the area of r equals to 2 at the first quadrant. Identify the value of alpha and beta. Put into the formula. First, it will be half first quadrant from 0 until pi over 2, then 2 squared theta theta. For theta theta, and because this is a constant of 4, the integration is very simple because this is in the terms of theta. So you integrate it, it becomes 4 theta. Substitute the value of beta. For pi over 2, you minus the value of alpha, 0. Simplify this, you will get 2 pi minus 0, where the final answer will be pi unit squared. Excuse me. So this is the full solution for to find the area of the first quadrant for r equals to 2, which is a circle with a radius of 1, a diameter of 2, and a center of 0, 0. Okay, let's try to do another one, which is r equals to 2 sine theta. Still a circle, but not the center is not the origin. So for 2 sine theta, put this into the formula again. I didn't write the full question for the first quadrant. Again, I will make it consistent so that you can compare. For the first quadrant, half integrate for the first quadrant from 0 until pi over 2. This time 2 sine theta squared delta theta. Okay. This time is a little bit different because there exists 4 sine squared theta delta theta. By using trigonometric identity, the one that I showed you previously, sine squared theta equals to 1 minus cos double angle 2 theta over 2. Before you integrate, please simplify this. 4 million 2 minus 2 cos 2 theta. When everything is nice here, then you can start to integrate. Becomes 2 theta. Integrate cos becomes sine. The sign, the negative sign is not changed there. Minus 2 sine 2 theta. The existence of double angle requires us to further divide it with 2. Oh, because I already integrate this. From pi over 0 until pi over 2. Okay, so you integrate it, becomes 2 theta minus sine 2 theta. Okay, next you need to substitute the value. Substitute for pi over 2 first, minus sine 2 pi over 2 closed, minus 2 times 0 minus sine 2 times 0. Close bracket. Proceed with the simplification. Solve the first bracket, we become pi minus sine pi 0 minus the second bracket 0 minus 0, and you will get half pi or pi over 2 unit squared. Let's look at the whole equation, whole solution, and try to retrace back the step. The crucial step, I repeat, is here where the first one you square root and also establish the parameter beta and alpha, and then change into trigo identity. You integrate and then you substitute it carefully, and you should get this answer. Okay, we already covered r equals to 2, a circle, r equals to 2 sin theta, also a circle. Let's try car diode this time. Of this, r equals to 2 plus 2 sin theta. Although it is not compulsory, it is advisable if you manage to visualize or sketch it first, the areas for this involved, for the car diode involved. So let me try to sketch it. Okay, 2 plus 2 sin theta, the shape will be like this. Two, 4, 2. From 0 until pi over 2, this is 4, this is negative 2. the area involved for the first quadrant should be this. Okay, so what will be the area that is enclosed within this cardioid for the first quadrant from 0 to until pi over 2? You replace it to the formula first. Squared theta theta. Okay, let's do the integration, the formula. Pi over 2, okay, 4 plus 2 times 2, 4 times 2, 8 sine theta plus 4 sine squared theta delta theta. Change the sine squared theta first. 1 minus cos 2 theta over 2 do not integrate yet. Integrate when everything has already been represented nicely. This will become 2 minus 2 cos 2 theta over 2. Okay, delta theta. No, I need to check this one back. This one will become minus 2 cos 2 theta. Okay, then we can integrate. 4 plus 2 here is 6, therefore will be 6 theta. Integrate 8 sine theta. Integrate sine, you change, it becomes a negative cos. Okay, this one cos becomes sine, the sign change will not change. The existence of double angle requires us to divide by 2. You will get 6 theta minus 8 cos theta minus sine 2 theta. Then you replace the values, starting with the beta first. Then you minus the value of alpha. Okay. Carefully calculate the value. Here there will be 3 pi. Cos pi over 2 is 0, so minus 8 times 0 is 0. Sin pi is 0, close. Minus 0, cos 0 is 1, so negative 8 minus 0, closed. Therefore, your answer will be half of 3 pi plus 8. Or 3 pi over 2 plus 4 unit squared. Let's retrace back our steps. Starting from the first one, this should be your full solution to find the area of cardioid 2 plus 2 sine theta for the first quadrant. You might try to find for another quadrant. As you can see, the For the third and the fourth quadrant, the area is much smaller. You can try to find those with the given alpha and beta, which is different according to the quadrants. For this example, it's a car diode of 1 plus 2 plus 2 sin theta. For the example in the slide is 1 minus cos theta, as you can observe there. They also need to change the cos squared theta into 1 plus cos 2 theta over 2 first. Although the calculation is much more simplified here, there's a shortcut there, but I assure you, if you retrace, do it again, step by step, you should be able to get this answer as well. Okay, for this first video, I think that we already know how to find the area enclosed within one polar curve only. For the next video, I will cover the area which is enclosed between two polar curves. Until then, thank you so much and see you in the next video. Goodbye.